Hey everybody, and welcome to our first lesson about trigonometry. In our unit about trigonometry, we're going to learn all of our trig functions, their ratios, how to use those trig functions to find missing sides and angles, and then we'll use that information to help us solve some application problems. But to begin, we've got to make sure we know kind of the basics. So let's talk about what exactly is a right triangle. Well, a right triangle is a triangle with a right angle. All right. It's important that that right angle is marked on the triangle, or we are told that that angle is 90 degrees. We cannot assume that an angle is 90 degrees. Must be told. Okay. There are 6 parts to every right triangle. A right triangle has 2 acute angles, and then 1 right angle, like we mentioned before, that 90-degree angle. And the longest side of a right triangle is called the hypotenuse. Okay? And the 2 shorter sides are both called legs. Okay? Now if you look down at the picture of a right triangle down below, we've got our right angle. Side C in this case is our hypotenuse. It's the longest side. It's always opposite of the right angle. And then sides B and A, those would be our legs. All right. Let's talk about our 3 trig functions. Our trig functions are sine, cosine, and tangent. They're abbreviated SIN for sine, COS for cosine, and TAN for tangent. Just know that those are always pronounced sine, cosine, and tangent. They can be found on your calculator, and they're typically right above the number keypad there, going from left to right: sine, cosine, and tangent. Now, a great way to remember what sine, cosine, and tangent are and what they represent are to remember the phrase SOHCAHTOA. SOHCAHTOA. SOHCAHTOA stands for sine is the opposite side over the hypotenuse. And I'll write it out like this. That's the opposite side divided by the hypotenuse. Ka means that the cosine is the adjacent side divided by the hypotenuse, and we'll talk about that adjacent side in just a second. That's the adjacent divided by the hypotenuse. And then TOA tells us that tangent is the opposite over the adjacent. Okay? That's the opposite side over the adjacent side. All right, great. Now, this term adjacent means next to. Okay, we'll talk about that as we look at some examples, but these are all as they refer to the angle that you're looking at. So as we look at an example over here, we're going to find the ratios using this triangle below. So I'm going to go ahead and write our friendly phrase over here, SOHCAHTOA. That's going to help us remember what all these ratios are. If I'm looking for the sine of A, that means I'm standing at angle A. Okay? And the sine of A is the opposite side divided by the hypotenuse. Okay? As I'm standing at A, the side that's opposite of me is little a, and my hypotenuse is C. All right, now let's kind of back it up and let's look at the cosine of A. I'm still looking at A, but now cosine is the adjacent over the hypotenuse. The adjacent is the side that's right next to it. Okay, that's side B. And my hypotenuse is still C. Okay, the tangent of A is that opposite side, little a, divided by the adjacent side, B. Okay, it's always good to remember that the hypotenuse is just the hypotenuse. The hypotenuse will never be the adjacent side. The opposite and the adjacent, those always refer to the legs. Okay, let's switch up a little bit and let's talk about I'm looking at angle B. Okay, now from B, I'm looking at the sine of B. Opposite of angle B is side B. And then that goes over the hypotenuse, C. The cosine of B is now the adjacent side. It's the leg that's touching the angle, and that would be my side A. That's divided by the hypotenuse. And then the tangent of B is going to be the opposite over the adjacent. All right. Hopefully this started to make a little bit of sense. Let's switch out those letters and put in some numbers. I've got a triangle right down here. I've got a leg of 3 and a hypotenuse of 5. If we use our Pythagorean theorem, we see that the other leg is 4. Okay. Now we can start finding the sine, cosine, and tangent. So the sine at angle A, if I'm at A, and sine is the opposite over the hypotenuse. So the opposite of angle A is 4, and the hypotenuse is 5. How about the cosine of A? Cosine is the adjacent over the hypotenuse, so the adjacent is 3, and the hypotenuse is 5. The tangent of A is the opposite over the adjacent, which is 4 over 3. Okay, let's flip it around. Let's look at angle B. All right. From angle B, the sine is the opposite 3 over the hypotenuse 5. The cosine of B is the adjacent over the hypotenuse, so 4 over 5. And then the tangent of B is 3 over 4. That's the opposite over the adjacent. All right, now it's your turn. You're going to find all of the ratios for the sine, cosine, and tangent at angles A and B. Now, remember, we can use the Pythagorean theorem to find our missing side over here. I'll help you out with that. That's 5 squared plus 12 squared. That's going to equal c squared. That is 25 plus 144 equals c squared. 25 plus 144 is 169. We all know 169 is one of our lovely perfect squares. That is 13. All right, now it's your turn. Go ahead and fill in all of our trig ratios and then check your answers. All right, let's see how you did. All right, the sine of A. It's the opposite over the hypotenuse, 5 over 13. The cosine of A. That's my adjacent over the hypotenuse. Oh, sorry about that. Let me fix my writing. It's 12 over 13. The tangent of A is the opposite over the adjacent. It's 5 over 12. Okay, now looking at B here, I'm going to change colors. The sine of B is the opposite, 12 over the hypotenuse. My goodness, having trouble with my writing here. That's 12 over 13. The cosine of B is the adjacent, 5 over the hypotenuse, 13. And then we have the tangent of B, which is the opposite, 12 over the adjacent, 5. Now you may be wondering, who cares? What do all these ratios do for me? Well, if you stay tuned, in the next lesson we're going to use these ratios to help us find some missing sides and then some missing angles. That's all for now. Tune into the next video.